yes, welcome everyone to GeoHug. So before we kick off today's session, I'd just like to take this time to acknowledge the traditional lands which we're all coming from today. I'm here on the beautiful lands of the Gadigal of the people of the Aurora Nation, and I'd like to pay my respects to the elders past, present and future. So I'm thrilled to have Adama Sidibe joining us today. So Adama has more than 10 years of experience in gold exploration in West Africa. He's worked in multi-stage exploration projects from grassroots to advanced and near mine. He has a solid background in orogenic gold and intrusive related gold exploration. So with his expertise, it is going to be awesome to learn from him today about RC sampling and lab analysis protocols applied to different gold deposits. So it's going to be a great session. Please use the chat. We'll have the chance to jump off mute and open up the floor at the end. And yes, thanks so much, Adama, for joining. It's wonderful having you.
Hi, everyone.
Hi.
I'm Adama Sidibe, exploration geologist in Mali, West Africa at Resolute Mining, with over 10 years of experience in orogenic gold, greenfield, brownfield, and near mine exploration based in gold. Thank you for giving me the opportunity to make a second presentation in this year. The first was on the West African grid success, where we talk about greenstone belt in West Africa, the different gold districts of West Africa, and exploration method adapted of each orogenic belt in West Africa. Today, I will talk about some sampling method and analysis adapted to some style of mineralization. As we all know, in mineral exploration for gold, it is essential to know good sampling practice and lab analysis method adapted of each type of deposit according to the grain size of the metal. We will discuss three analytical methods. We will shortly discuss with three analytical methods: the conventional fire assay, the screen fire assay, and the Leachwell, and some good practice and sampling practice. Okay. Next. Some exploration projects have failed since the early stage. Some gold deposit has been underestimated due to the sampling and analysis methods not suited to the style of mineralization. So this presentation will allow you to discuss some aspects of sampling and lab analysis to provide solution to common problems in exploration company. We will speak on the best sample recovery during RC drilling, the best splitter types, the lab analysis choice, and the resampling and reassay theory. A few keywords to remember in this presentation are the particle size, the sample recovery rate, the particle distribution, the rate at which particle go down to the cyclone, and during splitting. Okay. Now we'll discuss about some best sample recovery during RC drilling. As we know, sampling is an essential operation performed in many stages of mining projects. The success of an exploration project depends on the good recovery and good quality of sample. Generally, the company chooses 1 meter recovery or 2 meters recovery. To choose to recover 1 meter or 2 meter during the RC drilling depends on the type of deposit and the size of the gold particle. But 1 meter recovery is generally advised and frequent in mineral exploration. When the grain size are fine or to very fine, generally some gold company recover 2 samples. And when the grain size of gold are medium to coarse, it is not necessary to recover 2 samples. very risky method. Thus, the best method is to recover 1 meter from the assay drilling. And shortly, we will give some advice during the assay drilling operation. First, to make sure that the sample recovered from the cyclone is representative. Second, to make sure that the cyclone used is adapted to the scale of mineralization. Some cyclones are only adapted when the grain size is fine to very fine. A weight sample to estimate the recovery rate. Avoid the dust escape from cyclone as much as possible to avoid contamination and loss of sample particle. The cyclone must be cleaned at the end of every drill route or when it's required. It usually depends on the geologist's assessment. Use a good booster to avoid water on the sample. The water is the first source of contamination during the assay drilling. It is better to use a good booster to avoid this contamination. And the recovery rate and the quality of sample generally depend on the type of the hammer used, the type of the facies, and the type of the cyclone. And of course, the good professionalism of the geologist or the technician or the rig. The type of cyclone must be chosen according to the type of deposits. When gold is fine, medium to coarse or coarse. Here on this image, we have 3 types of cyclone on the right part. This type of cyclone will be used in all type of deposits with less segregation. All particles are homogeneous by gravity. Generally, the gold particle go down by natural gravity. With this type of cyclone, we have to recover all the particles with the good homogeneity by gravity. For me, it is this type of cyclone are better for all type of deposit. Okay, as we said above, the recovery rate is essential in assay drilling operation. The recovery rate depends on the size of the hammer used and the quality and the density of rock cross. We have several types of hammer size. 114 millimeter is the most used and provide a good recovery. There are other types of diameter. 711 millimeter, 76 millimeter, 89 millimeter. To calculate the recovery rate, we have to know the density of the rock. For example, sandstone, sedimentary rock, sandstone, the density is include between 1.8 to 3.2. The gabbro, the density is between 2.9 to 3.1. To the basalt, the density is 3.1. But the recovery rate calculation is you have to multiply the hammer diameter by 1 if the recovery is 1 meter. But if the recovery is 2 meter, you have to multiply by 2. Multiply the hammer diameter by 1, multiply by the density of the rock, multiply by 100. For example, for the basalt, generally the mafic rock are generally heavy than the sedimentary rock. For the basalt recovery rate with the hammer type 140 millimeters, we have 0.14 the hammer diameter in meter, 0.14 multiplied by 1 multiplied by the density of the basalt, 3.1 multiplied per 100, and we have 43.90, around 43 kilograms. With the sandstone, we have 35 kilograms, but this value may slightly vary. If there is the surplus of more than 15 kilograms, which means that the part of the next sample meter recovered in the current are recovered in the current meter. So you have to properly calculate this rate to estimate the recovery of whole sample during the drilling. Okay. The risky recovery. If you have seen this image, we have some risky recovery during the RC operation. The style of operation is a little adapted in fine and disseminated gold system, but very, very risky when gold is coarse or medium. Here, there will be a particle segregation. Because of natural gravity, the probability that the coarse particle converts toward the large compartment is very high, the small being the sample selected for the lab. Here we have too risky to have the segregation of particles. The system is as following. The samples are collected from the cyclone or splitter in calico bag and large bulk sample bag. This method is adapted where gold is fine to very fine. The splitter is directly incorporated into the cyclone. Or as you know, the splitter are the major source of potential contamination if not adequately cleaned after each sample and between holes. I advise to avoid this type of splitting during the RC operation. Very, very risky when the gold particles are medium to coarse. Sample movement. The sample movement are one of the source of contamination too. Generally, we have to ensure the sample bags are kept away from source of contamination. Example, when bags are too close to cyclone, the bag can mix with dust, water, and weather to the cyclone. Make sure that the bags are a little far to the cyclone. The process of removing sample can potentially involve contamination. Ensure the risks are minimized through correct fastening and labeling of bag. You have properly moved the bag, maybe 4 to 5 meters to the cyclone to avoid the contamination by the dust and the water. The sampling is the main critical success factor in the exploration change value. The success of an exploration project depends also to the type of splitter used during the sampling. It depends on the type of deposit too. The aim of sampling method is to choose the sample that represents the population. The sampling error is the error caused by observing only the sample instead of the whole of population of sample. You have to look at the sample, the subsample, and the whole population of the sample to avoid the sampling error. And the most important systematic error in the sampling is the contamination. The sampling equipment, the sample storage step, the water during the drilling, contamination during the splitting and recovery at the cyclone. The best splitting allows to have a best representative sub-sample to the original sample without segregation. The consequence of poor quality sample can lead to incorrect resource and reserve estimate, poor project development decision, poor grade control selectivity, incorrect design for process plan, poor mill to mine reconciliation, and incorrect financial model. So the decision to split the sample on the rig or in the exploration camp depend on the type of deposit as well. In the system where gold is medium to coarse, it is better to transport the sample to the exploration camp to minimize negative effect and sample inhomogeneity. In addition, there are too much pressure which we split the sample on the rig. We have to transport the sample from the rig to the exploration camp to properly do the best splitting and avoid scooping when samples are wet or damp. The best way is to dry them in the sun or in the oven before splitting them. Clean the splitter after each splitting. To never scooping the sample when it's wet or damp. You have to wait the sun or the oven. We'll speak with two types of splitter mostly used by exploration company. Here in photo, we have the multi-stage splitter. In this splitter, the sample go down in three steps. 100%, after 50%, after 25%. And after we will take the sample for the lab. From 25% before the final subsampling, the probability that the coarse particles are in the reject is very high. This type of splitter is adapted to the style of mineralization where the gold is disseminated fine to very fine and where the particle segregation is nearby possible. With the use of this type of splitter in the high negative sample, the Poisson distribution, the statistical Poisson distribution during the subsampling create a high probability to not obtain the main grade value. Generally, this type of splitter are used when the gold is fine to very fine. It is not better to use it when the gold particle are medium or coarse. But so because of the natural gravity, the probability that the coarse particle convert to the large compartment is very high. To avoid this type of splitter where when the gold particle are coarse or medium. But so this gravity may seem trivial to some geologists or technicians, but it is the reality of coarse particle during the sampling. Okay, we have the splitter is the 50-50 splitter. The splitter is designed to split a sample 50-50. Here, under the supervision of geologists and or technician geologists, each dry sample is split with 2 times. The half sample is put in the bag as a reject, and the second half is split again until to obtain the final sample between 2 or 4 kilograms. Do not split the wet or damp sample. Wet and damp sample are dry first for splitting in this type of splitter. The splitter must be washed between each with compressor air. Compressor air system. In the high Nugget Valley, we have the high probability to not obtain the main value, the main grade value. But this type of splitter reduce this probability and this possibility because of the sample are splitting 50-50, and by the gravity, the sample they go down by gravity 50-50. More than 90% are homogeneous here. The splitter is only designed to split at 50-50. But after the splitting, we have to make a traditional QA for the lab. But after we will discuss on that. And check the weight of the duplicate and the normal sample to get an idea of the quality of splitting, the variability versus the consistency of the sample load can help you to verify the quality of the splitting. After maybe 100 splitting or 200 splitting, the geologist must check the weight of duplicate and normal sample to be sure that the splitting are correct or not. It is I generally advise this type of splitter. It is the best splitter for all type of deposit, even the coarse to medium, fine to very fine. The splitter is the better. Some correct and incorrect sampling method. In this picture in left, you have an incorrect sampling method. The incorrect use, but it is better to avoid putting the sample bag at less than 90 degrees. This way of splitting is very incorrect and can create the particle segregation. It is the same here. If you are okay. The second image, we have the correct and the incorrect. The correct sampling, the sample are put vertically with particle segregation. But if you put the sample at 50 degrees or 80 degrees, it is possible to not get the representative sample for the lab. So make sure that the splitter put the sample at 90 degrees. It is very slow, but it is the better method to have the representative sample and to have the particle, the gold particle to the lab and to the reject. Maybe we have to use the reject for reassay and resampling to make sure that the splitting are correctly used. The scone splitter on the rig. This method is very, very risky too when the gold particles are coarse or medium. Here, the cone splitter on the rig. But even if the samples are mixed in the scone, the particle distribution will not be uniform. The large particle converts toward the reject, the big one, and the fine particle to the sample. It is incorrect to use this to do this method when the gold particles are coarse to medium. It is a little better when the particles are fine to very fine. But for me, it is not properly to use this the scone. It's very, very risky. Okay. Before gold analysis, we have to know the gold particle sizing and Nugget effect. The gold, with the estimation, the gold mineralization generally contain a combination of less than 100 nanometer if the gold is fine to very fine, and medium to coarse if the gold particles are higher than 100 nanometer gold particle. And gold deposit display Nugget effect for typical cores, channel sample support ranking from low to extreme Nugget effect. Less than 25%, we have low Nugget effect. Medium Nugget effect between 25 to 50, and high Nugget effect between 50 to 75. Extreme Nugget effect more than 75%, and with estimation are done by lab or geometallurgical method. Okay. You have to do several metallurgical tests to know if the Nugget effect is low, medium, extreme, or high. Okay. The lab analysis choice. Here, the first step is to do a careful due diligence at the lab. First, choosing the appropriate assaying technique for ore deposit is critical. We will discuss some basic assay technique for gold, like Fire Assay, Spring Fire Assay, and Leachwell. We have other methods like Assay and Gravimetry method. The choice of assay technique will depend on ore type, level of accuracy required, detection limit, result deadline, and the cost. If the project is at the early stage, it will be necessary to know the neighboring project mineralization style and wait the first drilling result. As well, I say above, do the metallurgical tests are required to determine particle size. This test will define the future method of the sampling and lab analysis. And the key word here is the metallurgical test to determine the size of gold particle. And after that, we will choose the lab analysis method. After the metallurgical test, If 95% of gold particles are less than 80 nanometer, it is properly and better to use the conventional fire assay for 30 gram or 50 gram fire assay. This method is cheap and quick. Only if the gold particle size are fine to very fine, less than 80 nanometer. The fire assay has the advantage to being less affected by ore mineralogy. Level of accuracy, high accurate for most type of gold mineralization, of fine gold mineralization, reliance on the experience of the fire assayer. For the detection limit, high accurate for most type of fine gold mineralization. The key word here is to fine. If the gold particles are fine, it is properly and no risky to use the conventional fire assay. If 95% of gold particles are between 80 nanometer and 200 nanometer, we have two methods. First, to test with the screen fire assay or to test with the Leachwell, the cyanidation. The large sample 1 or 2 kilogram screen fire assay or cyanidation Leachwell to use 1 or 2 kilogram fire Leachwell for Leachwell and fire assay on the tails. And if in the high negative sample, the segregation during the SIP sampling create a high probability to not obtain a main grade value. That's why we have to use screen fire assay or Leachwell when the gold particles are medium to coarse. The ore type, the screen fire assay has the advantage of being less affected by ore mineralogy. Screen fire assay determination are not skewed by gold particle size in the assay cell. For level of accuracy, when gold are coarse or medium, it is better to use this method. Here, the keyword for screen fire assay and Leachwell is the gold particle too. If the gold particle are between 80 to 220. Okay. Leachwell and Gravi. If gold particles are higher than 200 nanometer, we have to use Leachwell. We have to use only Leachwell, 2 kilograms of sample, and after that, we have to test the tails with the conventional fire assay. The best method is to analyze 2 kilograms of SIP sample, Leachwell, over 1 day, 24 hours bottle roll, and after that, we fire assay on the tails. The total gold will be the sum of Leachwell results and fire assay results after 1 day, 24 hours in bottle roll cyanide. And after that, to answer 5% of standard, 2 times 50 gram for Leachwell and 50 gram for fire assay. And after that, use 5%, use 5% of blank. For the key accuracy of the Leachwell is very, very, very important. I repeat, insert 5% of standard 2 times. One standard for Leachwell and one standard for conventional fire assay. And after that, insert 5% of blank. If the particles are coarse with the veggie, after each mineralization package, it is properly to insert 2 or 4 kilograms of blank sample to prepare to the lab due diligence. After each package of mineralization, insert the blank. If the negative effect are very, very high. The key word here is the gold particle. If the gold is free with the veggie, like in West Africa, like Agbau deposit in Cote d'Ivoire, in Mali, Kalana deposit, where the gold is free, and Tabakoto deposit in Mali. In this type of deposit, the best way is to use the Leachwell, not fire assay. The conventional fire assay will underestimate the deposit. Kalana, Akbau, Tabakoto, and other deposit where the gold are medium to coarse, and where we have the VG and RC or diamond. Okay. The reassay sample selection. The reassay sample selection depends of the type of deposit. If the gold particles are medium to coarse, we have to do the, and when the conventional fire assay we use in the gold context, some projects use the conventional fire assay with the high Nugget deposit. To do the reassay and resampling selection, we have first to use the 50-50 splitter, as I said above, and use the Leachwell method or screen fire assay method. And the selection is following. Use the 50-50 splitter. Second, select all sample displaying a grade bigger than 0.1 gram per ton, participating to the mineralization. Within the package mineralization, all sample with 0.1 gram per ton can use to reassay and resampling when the gold is free. Use screen fire assay or Leachwell. As a result, with Leachwell, low grade confirmed by fire assay could be doubled. If we have 1 gram per ton with the conventional fire assay in the coarse or medium grain gold, the screen fire assay or the Leachwell can give maybe 2 gram or 1.5 gram. And the screen fire assay could be positively increased too. When the gold particles are fine to very fine, we have just to review the splitting method from multi-stage splitter to 50-50 splitter and use and still use the conventional fire assay because the gold particles are are fine to very fine, and selected the sample with the grade higher than 0.3 gram ton. The key word here is to determine the gold particle, to change the splitting method, and to change the lab analysis method when the gold is fine to very fine. Fine to very fine, use Leachwell or screen fire assay. Fine to very fine, use conventional fire assay. Coarse to medium, use Leachwell or screen fire assay to avoid the underestimation of the deposit. If you read the last press release to Kalana deposit, in the past, IAMGOLD Kalana used the conventional fire assay. After that, Abnel Gold increased the deposit than 40% only with the reassay. We just took the sample and analyze them to this Leachwell method, and the deposit maybe from 1 million ounce, we have more than 1.5 million ounce only with the reassay. But the previous company done the wrong analysis method at Kalana deposit. The same over there in West Africa. So make sure to have the good metallurgical test before decide to use fire assay, screen fire assay, or Leachwell. Only the metallurgical test can allow you to determine this. Yes, as conclusion, the success of an exploration project depends on the best sampling practices and the right choice of lab analysis. The consequence of poor quality, as I mentioned above, can lead to incorrect resource and reserve estimates, poor project development decision, poor control selectivity, incorrectly designed project plan, poor mill to mine reconciliation, stalled project or reduced mine life, and incorrect financial model. The geologists have to train his technician and learn more and do the update for sampling and lab analysis method. In short, when the gold particles are fine to very fine, we can use the conventional fire assay and use the multi-stage splitter. And when the gold particles are medium to coarse, it is properly to use the 50-50 splitter and Leachwell or screen fire assay. If we use Leachwell, we have to make sure to put in the bottle roll cyanide over 20 hours, and after that analyze details with the conventional fire assay, and the total goal will be the sum of Leachwell value and fire assay value. this method is the best, more expensive, and smart. If for more questions, you can write to this address, adamaexplore@gmail.com. Thank you.